Hello, can you hear me? Yeah, thank you. So my name is Vid, I'm from the Blockchain Lab and today I'm going to talk about the project we are working on, which is called Masca. And it's a way to bring decentralized identity constructions directly to the MetaMask. So first, I'm going to talk about decentralized identity. I hope that you attended the previous workshop, which was about Polygon ID, which is also decentralized identity protocol, so I don't have to go into many details. Then I'm going to talk about Masca, which is a MetaMask Snap. Is anyone here already familiar with MetaMask Snaps? Okay. Then I'm going to talk about architecture of Masca. Some of the use cases that you can implement in your decentralized applications. I'm going to showcase some of the library packages and tools, and then I'm going to show some of the links. So after the presentation, I'm going to do a live demo. I wasn't smart as Tonio in the previous presentation, so we're going to do it live. I don't have a recording, but hopefully the internet will work. So what is decentralized identity? So currently, today, there are like two main approaches to decentralized identity. One is the on-chain approach and the other is off-chain. So for the on-chain, usually we have NFTs or zero-knowledge badges, which are tied to the blockchain addresses or smart contract wallets. We can represent public and private data in this forum, but there are some problems using these primitives for the identity. So one thing is there are fees associated with issuing NFTs. So if we want to like issue all our identity data for everyone on this world with NFTs, it would not be very scalable because someone would have to pay for all the fees. But there is like advantage is that data is always available on chain. So if we are trying to use the identity data in some of the smart contracts, we can always access this data. And then the other approach is off-chain data. So we have verifiable credentials and DIDs. So here we don't store the data on chain. We are storing it off chain in different forms. We can also represent public and private data. So we issue the data off chain, but if we want to make this data public, we can still put the data on chain. There are no fees associated with issuing the data, so this approach is much more scalable. But the data must always be shared with the entity that we want to share the data with. And there is also the question if we need global consensus on all private data, which means for all the identity data, which maybe is just important for us and like one other person on this earth, does it make sense that all the nodes of the blockchain need to like make the global consensus on all this data? So what are some of the challenges with off-chain solutions? So now we are not storing the data on-chain, we are storing it off-chain, and we have like many options. So one of the options is to use Ceramic Network. The other option is to just store verifiable credentials in your wallets. We can also store verifiable credentials on IPFS, or we can store them on Verida network, or like there are many different ways to store this data. And also in decentralized identity, which was also discussed in details in the previous workshop, is that we can do like some very interesting things with new cryptographic primitives. We have new elliptic curves like baby jub, which is used by Polygon ID, and we can do some very interesting things with zero-knowledge proofs. So the question is, if wallets support these all new features out of the box, or do we need to use one wallet for our Web3 identity, for our interaction with smart contracts, and then we need to use another wallet for the identity, which means that the users at the end will have to use two different wallets. Or also if there is a question if we need to implement all that logic for different data storage solutions and for different cryptographic primitives on each dApp, which means that the code that is handling the decentralized identity needs to be repeated on each dApp. But there are many upsides to use decentralized identity. Basically, we can enable new use cases with new cryptography. We have more control over our data, so our data is not on-chain. It is controlled by us, and we share the data only with the entities that we want to share the data with, and the privacy is much more enhanced in this way. So here is the trust triangle for decentralized identity. We have issuers, holders, and verifiers. So for example, issuer can be Ethereum friends, which issue you the ticket for ETHCC. So the holder gets the ticket, it stores the ticket in the wallet, and the verifier is then the guy at the entrance, which just verify the ticket. And for this verification, the verifier needs to check the cryptographic signature of the verifiable credential, and to get the public key of the issuer, it needs to go to the identity registry. So blockchain is basically used only for storing the metadata of the identities. So decentralized identity can be divided into two main parts. So first are the unique identifiers, and the other is data itself. So for the unique identifiers, we have decentralized identifiers, and for the data, we have verifiable credentials. So for the decentralized identifiers, we have different DIT methods. We can use the DIT method public key hash, which is basically just your Ethereum address. We can use the DIT method ENS, which is your ENS handle, or you can use DID method provided by Polygon ID. So we have like, for our identity, we can have multiple different DID identifiers, which are defined by different DIT methods. But what this DIT identifier tells you is that you can resolve this DID identifier, and you get the DID document. And this DID document is usually stored on the blockchain, or it can be constructed locally based on the DIT method. And it contains your metadata for your identity, which is most of the time your public key. So when you sign the data, you show the data to someone else, the other person can resolve your DID, gets the DID document, and it gets the public key, and then he can check the cryptographic signature of your data. And for the verifiable credentials, again, we have different formats. So this is like example of verifiable credential. It's a GM credential, which is used by the project Disco. So we have different formats. So we have JSON Web Tokens. These verifiable credentials are often used in more traditional systems, which rely on JSON Web Tokens. We can have JSON LD credentials, we can have EIP71 credentials, or we can have JSON Web Zero Knowledge credentials, which is used by Polygon ID. So for dApp developers, that's a lot of things to handle. dApp developers need to decide which DIT methods to support, and then when they decide for the DID method, they need to implement resolving the DIDs, updating the DIT documents. They need to decide which verifiable credential format to support. They need to decide which storage solutions they want to support. Do they want to connect to the Ceramic network or IPFS, or support like additional identity wallet? There are also different data exchange protocols, so you can share the credentials over OpenID Connect, or you can share the credentials over DITCOM. And then there is a question if the dApp developers should just support additional wallet, but then the users need to use two wallets on their application. So what is Masca trying to do is trying to reduce the hours of the dApp developers to get the decentralized identity support. So Masca is MetaMask Snap. So MetaMask Snaps are basically a way to write plugins or extensions for MetaMask. You can write your custom JavaScript code there. It runs in the separate execution environment. And you can basically implement any use case you want. And then you just provide the new RPC methods. So MetaMask itself provides RPC methods for the on-chain interactions. And with MetaMask Snaps, you can just add new RPC method to the MetaMask. So this is the architecture for the Masca. So Masca is running inside MetaMask. So basically, I put the purple fox here because they are currently available only on MetaMask Flask, which is the development version, but they are coming to the main MetaMask browser extension in September or October. We are using the same key management system for the cryptographic keys. So basically, all the keys for your identity are generated from the same seed phrase, which is in MetaMask, which means that if you migrate to another computer, you can just migrate with your seed phrase. So inside Masca, we are using the library Veramo for orchestrating the identity things. So Veramo is a very good open source library for decentralized identity. And inside we support different DID methods, and we also support different storage solutions. So if you are a dApp developer, when you want to store the verifiable credential, you can just call the one RPC method of Masca, and you specify to which storage solution you want to store verifiable credential. And we also have this configuration, so the users can decide where they want their verifiable credentials to be stored. So for example, if I want to store my passport as a verifiable credential, I personally wouldn't put that to Ceramic, for example, but maybe I would want to keep this credential locally. But if it's like the credential for like attending a conference, it's not so private, so it's fine to put it on the Ceramic. So we offer different RPC methods like save verifiable credential, get verifiable credentials, create verifiable presentation, switch DIT method, available DIT methods, and many more. So what are benefits of Masca? So you will be able to use Masca always when you will use MetaMask. You won't have to use another wallet. We are trying to develop universal decentralized identity solution by supporting different DIT methods and aggregating different verifiable credential storage solutions. And it's also highly configurable by users. So at the moment, each application is trying to stick to one DIT method because it's kind of hard to support additional DIT methods. But what we are trying to do is that the user can select which DIT method he wants to use, and then when he connects to some decentralized application, he's already using the DIT method he wants to use. And we are also trying to avoid backend APIs for these functionalities. So for example, verifying the credential happens inside the Snap, which runs in your browser extension, so there are no external dependencies to any servers. So what are some of the use cases? So one use case is credential-gated communities. So in the live demo that I'm going to show you, it's going to be like the chat that you can access only if you show the correct verifiable credential. There are also some other use cases like DAO governance based on reputation, offline peer-to-peer sharing of attestations, because for verifiable credentials, they're off-chain. When you share the credential, you don't have to have interaction with blockchain. You can share them directly in person. There are also like other use cases like social profiles and basically every other use case the developers come up with. So we implemented the Masca connector library, which is important for dApp developers. So basically, it's the SDK designed for the effortless integration of Masca. So this means that you don't have to call the RPC methods of MetaMask directly, but it just provides the abstraction, so you can call the functionalities of Masca like normal JavaScript functions. And yeah, this one. So here we are open source, so everything is open source. You can check the code on the GitHub, and the code for the workshop is also open sourced. We also have a Discord community if anyone has any questions. And here is the link to the workshop I'm going to show you. So if you want to follow along, you have to use your computer because MetaMask Flask is currently available only on PC. It's not available on mobile yet, so, but hopefully it will be at the end of the year. Okay, let's just wait a few seconds because the internet is slow. Okay, so you can. So we also implemented a decentralized application which can showcase the data you have saved, you have stored in Snap. So it's easier to get started. So all you have to do is connect with wallet. So this basically connects to your MetaMask Flask. And as you can see, we implemented the interface, which is very similar to the same user experience that is currently on the decentralized applications. So you can see that you are connected with a certain MetaMask account, and you can see the same DID methods. So basically, the cryptography behind this blockchain account is the same as behind this DID method. So we also support different networks for DID methods like Ethereum and Polygon, and we also enable to switch between different DID methods. So we have this load verifiable credentials. So when you click this button, it actually gets your verifiable credentials, which are stored locally in your Snap and also on the Ceramic network. Okay, so I have one verifiable credential here. We implemented the card view, which is more familiar to the actual documents we have in our real life, and also a table view, which just showcase more information. So as you can see, this verifiable credential is at the moment stored locally on Snap. But if we click on the verifiable credential, you can see the verifiable credential, you can see the issuer of the verifiable credential and the signature. And you can go to the settings and just put this verifiable credential on the Ceramic network. This is probably going to take a few seconds. You need to approve with MetaMask. And it's successfully stored. And the data stores are now updated. So we have this credential now also stored on the Ceramic network. And you can also create verifiable presentations for the credentials. You can select more of them or one. And you can also decide which proof format you want. So for example, some verifiers may rely only on JSON Web Tokens, while some verifiers might accept only JSON LDs. So basically, we support different formats. So this is the dApp that we developed, and then we just wanted to showcase how to do integration of Masca into any decentralized application. So we implemented this workshop demo, and I'm going also to show you the code for the integration. So here I have the React project created with Next.js. So for the development, all you need to do is you need to install the dependency Masca connector, which contains all the functionalities for the integration. So here we also have the connect button, which connects with the MetaMask Flask. So in the code, this looks like we have this navigation bar. And basically what happens is in this function, you call the MetaMask RPC method request account. You get the currently selected account of MetaMask. And then you need to enable Masca, which is imported from the Masca connector. The dApp developers can insert which DID methods are supported on this dApp, and then you get the Masca API from this, which is returned by the enable Masca. And then you can call the get DID with just like one line of code. You get the DID of the user, and then you can call get selected method, and you also get the method that is selected by the user. So I can query verifiable credentials here. So in the code, if we go to this page file, we have this query verifiable credential function. So here we are defining the filter. This means that, for example, user have 100 credentials in their Snap or Masca. So for a certain decentralized application, you are maybe interested only in one certain verifiable credential that is issued by the host of these verifiable credentials. So here we are checking the correct issuer of the verifiable credential, and we are checking that the verifiable credential is of the correct type. And then we just call the query verifiable credential function with this filter. So here, for example, this function is querying over all the storages, and maybe the certain decentralized application is maybe interested only on Ceramic. So here we could add options, and we could put store Ceramic, and now the verifiable credentials would be queried only from Ceramic network. And this is maybe necessary because some other application which is working with different decentralized application are maybe working together, and some supports only Ceramic for certain reason. So you can just check the Ceramic and add the Ceramic constraint here. So I queried my verifiable credential. I don't have the workshop credential yet, so you can try this at home. So the password here is Masca @ethcc6. I hope I got that wrong. Correct. So now I'm getting the credential from the issuer. And when the issuer returns this verifiable credential, I will be able to store it in Masca. So it's here, the password was correct, and I can store this credential in MetaMask Snap. So here, the credential, you can see the credential. And what's interesting here is that if I go back to the Masca dApp, if I refresh this page, the verifiable credentials now appears here because it's stored in our wallet. So the code for storing verifiable credential, it looks very similar to other functions. So basically what you need to do is call API.save verifiable credential. First parameter is credential, and then you just need to specify to which store these credentials should be stored. Now I can go to the restricted chat room. So now I have the correct verifiable credential. I can go to the gated chat room, which is accessible only if I have the workshop credential. And what happens here is that I create verifiable presentation with the correct verifiable credential. And that's interesting. Okay, let me refresh. Maybe I will just show you the code in the meantime. So here I'm creating the verifiable presentation. Again, you can call the API.create verifiable credential. I insert the credential and the correct proof format. And the issuer lets me in the gated chat room. So on the API side, this is how verifying the verifiable presentation looks like. So basically, the verifier checks that he issued this credential, that it is of the correct type, and that the verifiable presentation holder is actually the verifiable credential subject. Okay, so enter chat. This is how the look for entering the chat looks like. So basically, what happens here is that we are creating this verifiable presentation, and we are sending the verifiable presentation to the chat room backend API. I'm going to try getting to the chat room again. We are doing some changes in the last evening, so maybe it's not going to work correctly. Okay, sorry about that. So basically what would happen is that it would look like the same as the public chat room, but with the gated chat room, you can only access it with the correct verifiable credential. We are going to fix that, so you'll be able to try that at home. And that's it for my... No, that shouldn't be the problem. Yeah, thank you.
Hi, thanks for the talk. I think at the beginning of your presentation, and I also think in the architecture diagram, you kind of alluded to OpenID Connect, OIDC. Can you elaborate on the use case?
Yeah, so at the moment, the OpenID looks like that. For example, if you go to the issuer shows you the QR code, and you have to take the mobile application which supports the OpenID Connect protocol, and you scan the QR code, and then the protocol happens. So the protocol consists of multiple steps. First, you need to do proof of possession key, and then you need to show the issuer that you are actually the holder of this DIT, and then the issuer issues you the verifiable credential. So for our example, for example, if you go to the issuer's application, issuer doesn't have to show the QR code to the user. It can just so in the Masca, we support an additional RPC method which handles the OpenID Connect. So basically, the issuer could implement on the application the call to the Masca RPC node with the data that is relevant for the OpenID Connect, and the OpenID Connect would happen from Masca to the issuer. And we are doing very similar thing with Polygon ID. So at the moment, Polygon ID, if you want to get the credential, basically on the application, you get the Polygon ID QR code, you scan the QR code with the Polygon ID app, and then you need to scan another QR code for receiving the verifiable credential. So for example, we are also adding the new RPC method for Polygon ID. So basically, the application developer doesn't have to show 2 QR codes. It can just call the Maska RPC method, so the user can just use MetaMask for that.
For verifiable presentation, have you considered using ZKP, zero knowledge proof, for disclosing only a certain information?
Yeah, so basically for zero knowledge proofs, we are supporting it kind of for the Polygon ID, but this is relevant for the Polygon ID only. At the moment, we are currently most focused on the selective disclosure methods. So one method that is currently being popular is selective disclosure in combination with JSON Web Tokens. So basically, they are not really zero knowledge proofs. They're like selective disclosure. You can just disclose part of the credentials without revealing all the data. So for example, if you get your passport, you have first name, last name, and age. And when you want to buy something in store, you can just reveal your age because the store doesn't care about your first name and last name. So basically select disclosure, and for zero knowledge proofs, we are supporting Polygon ID, but for other DIT methods, we are not yet doing that.
Thanks. Hi, I may have missed it in the workshop demo, but does Masca also provide a UI or an SDK for the verifier side for them to manage which credentials they want to verify for their use case?
Yeah, so basically Masca is only the wallet part. So basically it's for the users and for application developers to add the wallet capabilities to their dApps. For issuers and verifiers, we have the separate projects where we spawn the issuer as a server and verifier as a server, so you can configure that in other repos.
Oh, perfect. So
it's open source, but so it's on our GitHub.
Okay, got it. So you guys offer also for the whole trust triangle,
yeah.
basically, but for today you basically showed the wallet.
Yeah, exactly.
Cool.
More question? No? Still have time.
Any questions? Yeah, there is.
Yeah?
Yeah.
I can also scream. I think the room isn't too looking. It's a user experience question. I'm coming as a non-techie to expose myself. I'm not a tech person, but I want to build a product for users that are not used to Web3. So they're not used to going through different apps to get an ID. Do you have a way to not have the MetaMask popping up every time I have to store an ID? Can you brand it in a way that it's interesting for a user and that they think it's one system? How do you approach this?
Yeah, so in Masca we have in settings the option to toggle pop-ups. So basically basically what you can do is disable pop-ups. So all these pop-ups that I got happen automatically. But it's you get the better user experience, but safety is then more problematic because you can just sign something that the dApp throws you and it's not really safe. So there is always between security and user experience trade-offs. So we kind of trying to do that with pop-ups so the users can decide if they want to have maybe worse user experience, but they know what they're doing. But they can also disable pop-ups if they want.
No more questions.
Thank you.
Thank you.